Learning objectives. In this lesson, you will be learning about the abstract data types, stacks and queues, and the following in detail. Definition of ADT, stack ADT, array implementation, FIFO, queue ADT, array implementation. Definition of ADT. Solving a problem involves processing data, and an important part of the solution is the careful organization of the data. In order to do that, we need to identify the collection of data items, basic operation that must be performed on them, abstract data type, a collection of data items together with the operations of the data. An ADT consists of a data declaration packaged together with the operations that are meaningful on the data while embodying the structure principles of encapsulation and data hiding. An abstract data type is a data type packaged with the operations that are meaningful for the data type. We then encapsulate the data and the operations of the data and hide them from the user. Abstract data type, definition of data, definition of operations, encapsulation of data and operation. In computing, we view data from three perspectives. Application level, view of the data within a particular problem. Logical level, an abstract view of the data values, the domain, and the set of operations to manipulate them. Implementation level, a specific representation of the structure to hold the data items and the coding of the operations in a programming language. Stack ADT. An implementation of ADT consists of storage structures to store the data items and algorithms for basic operation. An array is a named collection of homogeneous items. An item's place within the collection is called an index. If there is no ordering on the items in the container, we call the container unsorted. If there is an ordering, we call the container sorted. Stack. A stack is a restricted linear list in which all additions and deletions are made at one end, the top. If we insert a series of data items into a stack and then remove them, the order of the data is reversed. This reversing attribute is why stacks are known as last in, first out data structures. A stack is an abstract data type in which accesses are made at only one end. LIFO, which stands for last in, first out. The insert is called push and the delete is called pop. Push an item into the top of the stack. Insert an item. To add, push an element, either increment top and store the element in stk top or store the element in stk count and increment count. Increment top of stack by 1. Set stack top of stack equals x. Pop an item onto the top of the stack. Delete an item. To remove, pop an element. Either get the element from stk of top and decrement top, or decrement count and get the element in stk of count. Set return value to stack of top of stack to decrement top of stack by 1. Stack ADT. An implementation of ADT consists of storage structures to store the data items and algorithms for basic operation. An array is a named collection of homogeneous items. An item's place within the collection is called an index. If there is no ordering on the items in the container, we call the container unsorted. If there is an ordering, we call the container sorted. Stack class. Attributes of stack. Max top, values. Operations of stack. Push is full, top, pop, display stack. Is empty. Let us consider the initialize stack operation. Because the value of stack top indicates whether the stack is empty, we can simply set stack top to 0 to initialize the stack. Empty stack. We have seen that the value of stack top indicates whether the stack is empty. If stack top is 0, the stack is empty. Otherwise, the stack is not empty. Full stack. Next, we consider the operation is full stack. It follows that the stack is full if stack top is equal to max stack size. Copy stack. The function copy stack makes a copy of a stack. The stack to be copied is passed as a parameter to the function copy stack. We will, in fact, use this function to implement the copy constructor and overload the assignment operator. Constructor and destructor. The definition of the constructor and destructor as follows. The functions to implement the constructor and the destructor are straightforward. The constructor with parameter sets the stack size to the size specified by the user, sets stack top to 0, and creates an appropriate array in which to store the stack elements. If the user does not specify the size of the array in which to store the stack elements, the constructor uses the default value, which is 100, to create an array of size 100. The destructor simply deallocates the memory occupied by the array, that is, the stack, and sets stack top to 0. Copy constructor. The copy constructor is called when a stack object is passed as a value parameter to a function. It copies the values of the member variables of the actual parameter into the corresponding member variables of the formal parameter. Overloading the assignment operator, equal sign. Recall that for classes with pointer member variables, the assignment operator must be explicitly overloaded. Stack header file. Now that you know how to implement the stack operations, you can put the definitions of the class and the functions to implement the stack operations together to create the stack header file. For the sake of completeness, we next describe the header file. Suppose that the name of the header file containing the definition of the class stack type is mystack.h. Stack ADT. Elements of stack are stack, item element max stack size. Create an empty stack whose maximum size, Boolean is full insert item into top of stack and return. Element pop, remove and return the item on the top of the stack. Boolean is empty. Insert item into the top of stack. Declare member functions for all the public operations that are called for by the ADT. All member functions after public are accessible by any client in your program wherever there is an object of this class. Access specifier. All members after private are only accessible to the member functions of this class. Information hiding. Data members are always private, so that the object's client cannot change the data directly. Data can be accessed only by using the public member functions. Now decide how to implement the operations. int top index maximum capacity of the array. Example code is given here for the array stack operation. Stack applications. Real life. Pile of books. Plate trays. More applications related to computer science. Program execution stack. Read more from your text. Evaluating expressions. Postfix expressions calculator. For example, the expression a plus b multiplied by c in a postfix expression is a, b, c star plus. Scan the expression from left to right. When an operator is found, back up to get the required number of operands. perform the operation and continue. To simplify the complexity of the function main, we write 4 functions: evaluate expression, evaluate operations, discard expression, and print result. The function evaluate expression, if possible, evaluates the expression and leaves the result in the stack. If the postfix expression is error-free, the function print result outputs the result. The function evaluate operations evaluates an operator, and the function discard expression discards the current expression if there is any error in the expression. From this algorithm, it follows that this method has 5 parameters. Parameter to access the input file, parameter to access the output file, parameter to access the stack, parameter to pass a character of the expression, parameter to indicate whether there is an error in the expression. STL class stack. Stack is an important data structure. The standard template library provides a class to implement a stack in a program. The name of the class defining a stack is stack. The name of the header file containing the definition of the class stack is stack. Operation effects. Size returns the actual number of elements in the stack. Empty returns true if the stack is empty and false otherwise. Push item inserts a copy of item into the stack. Top returns the top element of the stack but does not remove the top element from the stack. This operation is implemented as a value returning function. Pop removes the top element of the stack. In addition to the operations size, empty, push, top, and pop, the stack container class provides relational operators to compare 2 stacks. C++ runtime stack. The C++ runtime system keeps track of the chain of active functions with a stack. When a function returns, its frame is popped from the stack and control is passed to the method on top of the stack. Array-based stack. A simple way of implementing the stack ADT uses an array. We add elements from left to right. A variable keeps track of the index of the top element. The array storing the stack elements may become full. A push operation will then throw a full stack exception. Limitation of the array-based implementation, not intrinsic to the stack ADT. First in, first out, queue ADT. A queue is a first in, first out data structure. Items are removed from a queue in the same order as they were inserted. Like a stack, a queue is also a list. However, with a queue, insertion is done at one end while deletion is performed at the other end. Accessing the elements of queues follows a first in, first out order. Like customers standing in a checkout line in a store, the first customer in is the first customer served. Queue operations. Initialize queue. Initializes the queue to an empty state. Is empty queue. Determines whether the queue is empty. If the queue is empty, it returns the value true. Otherwise, it returns the value false. Front. Returns the front, that is, the first element of the queue. Prior to this operation, the queue must exist and must not be empty. Back. Returns the last element of the queue. Prior to this operation, the queue must exist and must not be empty. Add queue. Adds a new element to the rear of the queue. Prior to this operation, the queue must exist and must not be full. Is full queue. Determines whether the queue is full. If the queue is full, it returns the value true. Otherwise, it returns the value false. Delete queue. Removes the front element from the queue. Prior to this operation, the queue must exist and must not be empty. Basic operations. Dequeue. Delete the element at front of the list. Enqueue. insert an element at the rear of the list. Implementation of queue. A queue is a first-in, first-out data structure. This is accompanied by inserting at one end, the rear, and deleting from the other, the front. To insert, put new element in location 4 and set rear to 4. To delete, take element from location 0 and set front to 1. When an item is enqueued, make the rear index move forward. When an item is dequeued, the front index moves by one element towards the back of the queue, thus removing the front item, so no copying to neighboring elements is needed. Function. Adds new item to the rear of the queue. Preconditions. Queue has been initialized and is not full. Post conditions. New item is at rear of the queue. Queue overflow. The condition resulting from trying to add an element onto a full queue. Function. Removes front item from queue and returns it in item. Preconditions. Queue has been initialized and is not empty. Post conditions. Front element has been removed from the queue and item is a copy of removed element. Queue underflow. The condition resulting from trying to remove an element from an empty queue. Circular array. When a new item is inserted at the rear, the pointer to rear moves upwards. Similarly, when an item is deleted from the queue, the front arrow moves downwards. After a few insert and delete operations, the rear might reach the end of the queue and no more items can be inserted, although the items from the front of the queue have been deleted and there is space in the queue. We can treat the array holding the queue elements as circular, joined at the ends. Elements were added to this queue in the order 11, 22, 33, 44, 55 and will be removed in the same order. Use front equals front plus 1% of my queue length and rear equals rear plus 1% my queue length. Empty queue and full queue. If the queue were to become completely full, if we were then to remove all 8 elements, making the queue completely empty. Solution 1. Keep an additional variable. Solution 2. Slightly more efficient. Keep a gap between elements. Consider the queue full when it has n-1 elements. Queue class. Attributes of queue. Front or rear index. Counter. Number of elements in the queue. Max size, capacity of the queue. Values. Point to an array which stores elements of the queue. Operations of queue. Is empty. Return true if queue is empty, otherwise return false. Is full. Return true if queue is full, otherwise return false. Enqueue. Add an element to the rear of the queue. Dequeue. Delete the element at the front of the queue. Display queue. Print all the data. Initializes queue to empty state. First element added at the first array position. Initialize queue front to 0 queue. Rear to max queue size 1 count to 0. Queue of int size equals 10. Allocate a queue array of size. By default, size equals 10. Front is set to 0, pointing to the first element of the array. Rear is set to -1. The queue is empty initially. Front and rear. Front. This operation returns the first element of the queue. If the queue is non-empty, the element of the queue indicated by the index queue front is returned. Otherwise, the program is terminated. Rear. This operation returns the last element of the queue. If the queue is non-empty, the element of the queue indicated by the index queue rear is returned. Otherwise, the program is terminated. Constructor and destructor. Constructor. To complete the implementation of the queue operations, we next consider the implementation of the constructor and the destructor. The constructor gets the maximum queue size from the user, sets the variable max queue size to the value specified by the user, and creates an array of size max queue size. If the user does not specify the queue size, the constructor uses the default value, which is 100, to create an array of size 100. The constructor also initializes queue front and queue rear to indicate that the queue is empty. Destructor. The array to store the queue elements is created dynamically. Therefore, when the queue object goes out of scope, the deconstructor simply deallocates the memory occupied by the array that stores the queue elements. More specialized data structure. Similar to queue having front and rear. Items are removed from the front. Items are ordered by key value so that the item with the lowest key or highest is always at the front. Items are inserted in proper position to maintain the order. Used in multitasking operating system. They are generally represented using heap data structure. Insertion runs in O of n time. Deletion in O of 1 time. DQ. A DQ is a double-ended queue. Insertions and deletions can occur at either end. Implementation is similar to that for queues. DQs are not heavily used. More versatile data structure than stack or queue. Example, policy-based application. Example, low priority go to the end, high go to the front. Applications of queue. Simulation. The main goal of the computer simulation is to generate results showing the performance of an existing system and predict performance of a proposed system. Programming language implements algorithms with functions. Functions implement object actions. Objects represented as classes. Class member variables describe object properties. Function members describe actions on data. Queues represent the basic data structure. Queues of the objects are waiting to be served by various servers. Consist of servers and queues of objects waiting to be served. Object that provides the service. Object receiving the service. Time required to serve a customer. Model system consisting of a list of servers waiting queue holding the customers to be served. Number of servers, expected customer arrival time, time between customer arrivals, number of events affecting system. Clock implemented as a counter. Passage of time, implemented by incrementing counter by 1. Example, run for 100 minutes. Counter starts at 1 and goes up to 100 using a loop. Customer has a customer number, arrival time, waiting time, transaction time, departure time. With known arrival time, waiting time, transaction time, can determine departure time. Add these 3 times. Implements customer as an ADT. Member function definitions. Functions. Set waiting time. Get arrival time. Get transaction time. Get customer number. Server. At any given time unit, server either busy serving a customer or free. String variable sets server status. Every server has a timer. Program might need to know which customer served by which server. Server stores information of the customer being served. 3 member variables associated with the server status, transaction time, current customer. Basic operations performed on a server. Check if server free, set server as free, set server as busy, set transaction time, return remaining transaction time. If server busy after each time unit, decrement transaction time by 1 time unit. Member function definitions. A server list is a set of servers. At any given time, a server is either free or busy. For the customer at the front of the queue, we need to find a server in the list that is free. If all the servers are busy, the customer must wait until one of the servers becomes free. Thus, the class that implements a list of servers has two member variables. One to store the number of servers and one to maintain a list of servers. Using dynamic arrays depending on the number of servers specified by the user, a list of servers is created during program execution. Some of the operations that must be performed on a server list are as follows. Return the server number of a free server. When a customer gets ready to do business and a server is available, set the server to busy. When the simulation ends, some of the servers might still be busy, so return the number of busy servers. After each time unit, reduce the transaction time of each busy server by 1 time unit. And if the transaction time of a server becomes 0, set the server to free. Waiting customer queue. Upon arrival, the customer goes to the end of the queue. When server available, customer at front of queue leaves to conduct transaction. After each time unit, waiting time incremented by 1. Derive class waiting customer queue type from class queue type. Add additional operations to implement the customer queue. Conclusion. Thus we learned about abstract data types, stacks and queues and the following in detail. Definition of ADT, stack ADT, array implementation, FIFO-Q ADT array implementation.